Hello, ladies and gentlemen. Welcome to Math 31 Calculus, Chapter 2, Derivatives, Lesson 7, the Quotient Rule. So, today we're going to be explaining the derivative theorems for sum and difference. F divided by g prime of x equals f prime of x g of x minus f of x times g prime of x divided by g of x squared. We're going to be explaining the derivative theorems for quotient using practical examples, for the quotient, and we're going to be deriving the quotient rule from the product rule. Now, the quotient rule, f divided by g prime equals f prime g minus f g prime divided by g squared, or top divided by bottom prime equals bottom times top prime minus top times bottom prime divided by bottom squared. Now, Leibowitz. Okay, spell Leibniz. Using Leibniz notation. This would be d of x times the derivative of f of x minus f of x divided by g of x squared. So if you for Leibniz, forget. Anyway, that's the way you'd write it out. Anyway, so for f of x equals 1 minus x squared divided by 1 plus x squared, find f prime of x and compare the graphs of f of little x, and f prime of x. So notice we're using f again just to confuse you, but I'm going capital F. So this would be 1 plus x squared times the derivative minus 2x, subtract f of x, 1 minus x squared times the derivative, which would be 2x, divided by 1 plus x squared. Okay, now that becomes let me see, multiplying this all out, minus 2x cubed minus 2x cubed for 1 plus x squared minus 2x cubed. Okay, that cancels out, so this becomes minus 4x over 1 plus x squared. That's the derivative. Now, graphing it, a little more difficult. And there's no way in hell I'm doing this with a graphing calculator because I'm old. I'm not doing a table of values for this crap. So grab your graphing calculator. Hurry up because I'm getting old. When you graph them, f of x goes something like this. F prime goes a little more like it's a little smoother. It's not a cusp per se. It goes like that. Yeah, that does look too much like a cusp. It's a fairly sharp curve, but anyway. So when you graph it, it should look like that. Right? That's what Mr. Graphing Calculator says, and I'm not arguing with it. Now, find the equation of the tangent line to the curve y equals square root of x divided by x plus 1 at the point 4, 0.4. Alright. Y equals x to the 1/2 for x plus 1. Y prime, d dx, whatever, will be x plus 1. That's going to be 1/2 x to the minus 1/2 minus x to the 1/2 times x plus 1, the derivative, that'll be 1 all over x plus 1 squared. Now, okay, so this is going to be, let me see. X to the 1/2. Yeah, gotta multiply this out, sorry. So this becomes 1/2 x to the 1/2 plus 1/2 x to the minus 1/2 minus x to the 1/2 all over x plus 1 squared. Sorry, I was looking at it and going, do I have to multiply that crap out? I gotta. Now, here I want to point something out. Notice I've got a whole bunch of x to the halves. X to the plus 1/2, x to the minus 1/2. Now, let me see. Can I combine terms? Yes. I have 1/2 x to the 1/2, so this becomes 1/2 x to the minus 1/2 minus 1/2 x to the 1/2. Alright? Oh, sorry. All divided by x plus 1 squared. So far, so good. Now, you should be able to do this. Everybody take a deep breath, because here's where it takes a left turn into, oh my god, I got to do 20 minutes of simplifying. It just seems like 20 minutes. Now, notice both the terms in front have a half. So that means I can take my denominator and go x. So this is x to the minus 1/2 minus x to the 1/2. Okay? Now, I want you to realize here, I can rationalize the numerator. Well, I can start. Multiply top and bottom by square root of x. Now, why am I doing that? Oh, sorry, I should be saying x to the half. What happens here? X to the half times x to the minus 1/2 is what? We add our exponents. Minus 1/2 plus 1/2 is 0. So we get x to the 0 or 1 minus x over 2 times x to the half x plus 1 squared. Now, okay. Now notice how we've simplified this. Now, usually, we'll write that as we'll write it like that. The denominator 2 square root of x, x plus 1, so times x plus 1 squared. Now, notice how much nicer and simpler that is than that thing we had above. So when you see stuff like that, x to the halves, or x to the minus halves, be prepared to rationalize, multiply, or factor out. Okay? Now, so far so good. Now this is half the question. The question, find the equation of the tangent line. We've just found the slope at the point 4, 0.4. So we need to go f prime of 4, which is what? Okay, f prime of 4, we plug in 1 minus 4 over 2 times the square root of 4 times 4 plus 1 squared to get our slope. 4 plus 1 is 5, 5 squared is 25, 3 over 100, which is 0.03. So that's my slope. Now, that means I gotta go y minus y1 equals m x minus x1 to find the equation. So this is y minus, the point was 0.4, wasn't it? Yes. equals 0.03 times x minus 4. All right, so this is at 0.4. Did I screw that up? Let me just double check. Oh, minus 3. Yes, sorry. It's going up. So it's minus 3 plus 12. My bad. Yes, I can hear you screaming at me. Minus 0.03 x plus 0.52. So that's my slope. Okay, now I'm going to pause there because this is getting kind of long, but I want you to see what's expected of you. Any questions, shoot me an email. Otherwise, good luck.